Hi guys, I'm Gio Joy from T-John College of Pharmacy, Bangalore. In this video, I'm going to talk about gram staining along with its principle and procedure. So gram staining is a differential staining mechanism in which the bacteria is differentiated into two large groups, namely the gram positive and the gram negative. It was developed by Christian Gram in the year 1884. So the main principle which involves gram or the gram staining revolves is the composition of the cell membrane. So gram staining is used to establish the number of bacteria in a clinical specimen and to differentiate the bacteria whether it is a gram negative or a gram positive. Moving into the gram staining principle and procedure, the main principle of gram staining is based on the cell membrane composition. The gram positive bacteria contains about 50 to 90% of peptidoglycan, whereas gram negative bacteria contains only 10% of peptidoglycan and has a high lipid content. And now moving on to the principle of the gram staining, four chemical reagents are used. One is the primary stain, which is the crystal violet. Second is a mordant called the gram iodine. Third one is a decolorizer, which can be either alcohol or acetone. Fourth is a counter stain called safranin. So moving into the principle, the first step, we add crystal violet to a heat fixed smear of bacteria. Heat fixation is done to make sure that the bacterial cells doesn't flow off during the whole procedure. So when the primary stain, that is the crystal violet, is added, the whole smear is stained into a purple or violet color. And that's the first step. And the second step, a mordant, a gram iodine is added. So mordant indicates a substance which holds or retains something. So here the iodine complexes with the crystal violet, resulting in a complex formation called as the CVI, which is nothing but the C crystal violet iodine complex, which gives a purple or violet color. And in the next step, that is the third step, we add a decolorizer, which is either acetone or alcohol. So what happens here is the alcohol reacts with the lipids. As we know, alcohol is soluble, lipids are soluble in alcohol. It reacts with both the lipid layers. As we see in gram positive, it has many multi-layer, say many layers of peptidoglycan, and whereas in gram negative, it has high lipid content and only about 10% of peptidoglycan. So what happens in the gram negative is that the alcohol or the acetone reacts with the lipids, and during washing of the slide, it makes the peptidoglycan layer to be washed out along with the washing. Whereas since gram positive has multi layers of peptidoglycan, only a few layers of peptidoglycan is washed away during the washing. And in the last step, the counter stain, that is the safranin, is added. So since gram positive already has the primary stain, the safranin is masked by the primary stain, that is the crystal violet, whereas the gram negative bacteria, it loses its peptidoglycan and is in a clear state. When counter stain is added, that is a secondary stain, safranin is added, it attains the color of the safranin and gives a pink or red color. So in the final procedure or at the final step, we can identify the gram positive bacteria as purple or violet color, whereas the gram negative bacteria is visible in red or pink color. But gram staining is not applicable to all microorganisms or bacteria. For example, Mycobacterium is called a variable stain since it doesn't give answer for gram staining. So this is all about gram staining, its principle and procedure. Thank you for watching.